Hello. Hi guys, good morning. Firstly, ki halchal sab changa si? If yes, then just do let me know down below. And for sure, how many questions you solved today? Yesterday, for sure, the folks who did yesterday, for sure, they also should be here and should be telling how many questions they solved today. And just a quick check, audio, video, everything good, fine, looks good. If the folks are here, 6, okay. People, Aditya, Aditya is back. Cool, hi Aditya, hi. How many questions you folks solved? Okay, I can see some less people joining in, but cool, no worries. Yeah, the contest was, yeah, Suyash, good morning. You guys, like, woke up until 1 o'clock in the night and still gave the contest in the morning. That's awesome. Cool. Any other folks in the stream? We will start 3. That's awesome. Which one you could not solve? Like fourth one. But fourth one was actually easy one. Like, not sure. Kuntia or like Kantia. I'm not sure if I'm pronouncing that out right. Yo. Akash 3. Shalini 3. I just want to know, what is that one question you guys could not solve? Was it the fourth question or some other question? Because what I figured out was fourth was actually easier than other questions. So yeah, yesterday solved 2, today 1. No worries at all, Aditya. Like, it says that okay, with time we just learn stuff, we get to know stuff, and that help us to actually get in problem solving better. So no problems at all if we are like, if you're not able to solve initially in the beginning. Even if you solve one, even if we cannot solve any problem, even if we tried, that also is best. But before that, Suyash Zor wala question nahi ho paya. That is, yeah, I was thinking like which, because the fourth question was actually not that hard. So basically, okay, the third maybe or the second maybe. So yeah, what I also consider is question 2 was actually the trickiest one. So that was actually great. But before that, the folks, yeah, you are 13 folks, right? Just smash that like button and at least reach to 10 likes. No, we are actually constant viewers, right? I'm digging, like I'm bringing continuously. You are coming back continuously. So like smash that baby up and let's reach to 10, and then we will for sure start with the first one itself. So yeah, cool. Let's start with the first problem itself, which is, I'll just quickly switch to my folks. Let's smash that baby, no? Bichari, my stream is asking for like being spanked by your likes, and you're not spanking likes on it. No, it doesn't count as this, you know? Cool. Start with the first problem. See, the first problem will actually, although it is again a problem in which a concept is being used, which I have told earlier also, but still we will actually see the concept of cycles in an array and how to go on these cycles. But although for the folks who are new maybe and the folks who are old, were they able to find how to find the cycles, which means okay, how to go on repeatedly in the array by just doing a modulo? For the folks, because I have actually told this concept previously in the last 1 month, whatsoever weekly contest we had and whatsoever the questions we do daily, in that I have told this concept for sure. Then do you know that concept, yes or no? If not, then no worries at all. In today's video, we will see this concept for sure. It's an easy problem. It can be solved by many ways, but it's actually a very good concept that you must know for sure. Cool. Starting with the first problem itself, find the losers of a circular game. But before that, if the folks are joining in and if they have been constant viewers, then for sure, if your likes would be awesome. Cool. Find the losers of the circular game, which means okay, there are n friends that are playing a game. Cool. N friends playing a game. The friends are sitting in a circle. See, Magmas, whenever the something like that as a circle comes in picture and you have to go on the circle, and the circle is array. So basically representing an array and performing operations on the array to replicate that stuff in a circle, there is a standard concept of moving k steps by doing a modulo that you should be for sure knowing, and it is the one thing which was actually required in this problem. But yeah, it is actually a concept which you should know. If you don't know, then for sure, please make sure that in this video today you go home, or like you are actually at your home, but yeah, you go home by knowing this concept. Cool. The friends are sitting in a circle. Cool. There are friends, they are just sitting in a circle. Number from 1 to n, which means okay, 1, 2, 3 up till total n. Cool. In the clockwise direction, as in the clockwise direction. More formally, moving clockwise, ith friend brings you to the I plus 1th friend, which means as I move clockwise, I have moved from the first friend to the second friend, then from second to the third, and then so on and so forth. For the I plus 1th friend. Now, I is from 1 to n because we have n friends in the circle. Now, and moving clockwise from the nth friend brings back you to the first friend, as we showed above. If we just move clockwise from nth friend, then we will reach back to the first friend. Cool. Now, the rules of the game are as follows. First friends receive the ball. Okay. The ball starts from the first friend itself, which means I'll just change the color. Let me change the color. First, like ball starts from the first friend. Cool. Ball starts from the first friend. Now, after the first friend passes it to the friend who is k steps away from him in the clockwise direction, which means let's imagine k is nothing but 2, which means he will pass this ball to my friend 3, which means k steps away. I will pass this ball here. Then in the next step, okay, after that the friend who receives the ball, which means here the ball is received by the third friend. After he receives the ball, he should pass it to the friend who is 2 into k steps away, because here the steps were k. Let's say I imagine k as this, but next time when he will pass the ball, he will pass the ball next time as 2 into k steps, and then when let's say it reaches here, then maybe it has to pass the ball, then it will pass the ball in how many gap? K into 3 gap. That is how they will keep on increasing your k and will keep on passing your ball. Now, and for sure the ball is being passed in the clockwise direction, so that is one thing which is for sure to us. Now, after that the friend who receives the ball should pass it to the friend who is 3 into k, as we saw above also, from the clockwise direction. Cool. In other words, ith friend, the friend who is holding the ball right now, should pass a ball to the I into kth friend. Cool. Now, steps are as in the simple. In the first step, the number of jump required is k. In the next jump is 2 into k. Next jump is 3 into k. Next jump is 4 into k. Next jump is 5 into k. It is how the jump will increase every time as I go on and keep on pushing my ball. Cool. Now, away in the clockwise direction, the game is finished when some friend receives the ball for the second time. Any person who receives the ball again, which means let's say after this n it just reached on back to 3, which means it has again 3 had occurred once, but even if it occurred again, then I have to stop the game. For sure my game has ended. Cool. The losers of the game are defined as, the losers of the game are the friends who did not receive the ball in the entire game, which means here you will see the 2, let's say he never received the ball, maybe other number also. So after the game has ended, and when the game ended when one person receives the ball again, then the game ended. Now the loser of the game are the persons who never received the ball at all, which means 2 and other numbers, not 1 and not 3, not this number at all. Cool. Now we have to find what? We have to find the loser of the game itself, which means out of these n friends, integer k, which will be, see, n friends shows me, okay, I have n friends, 1, 2, 3 up to so on and so forth. Or I can say, okay, 0, 1, 2, 3 up till n minus 1. I just number my friends. Now, integer k, which means at every jump, because my ball starts from this friend, it will have to have a jump of k, then will reach this friend, then jump of 2 into k, and so on and so forth. The jump will go on increasing. Return the answer array which will indicate the losers of the game in the ascending order. Cool. I will just find the losers of the game in the ascending order. Now, one thing for sure which comes in my mind is, what I can easily do is, firstly, let's look at the constraints. Very small. No worries. What comes first in my mind is, I will have my array of n friends, because see, I can replicate my circle in the form of an array, because I can replicate these steps of being clockwise in the form of an array itself. And that is the reason I will just replicate the same stuff for an array, which I will show you by this example of n equal to 5 and k equal to 2. So basically n equal to 5 and k equal to 2, which means I have 5 friends. So basically whenever we have to move clockwise in a circle, I just represent that same stuff in the form of an array and choose an array itself. So I will have an array of basically these 5 values. Cool. Now initially the ball, see initially the ball is like no one is having the ball, right? But as we start the game itself, the ball will be for sure with the first boy, which is the first friend. In the next step, the ball has to go to what? Jump of 2, because k, it has to make a jump of k, so it will reach from 0 to 2. Okay, he will just visit the ball. The ball will be visited by the friend number of index 2. Then at the next step, I have to go on to k equal to like 2 into k, which is actually a 2 into 2, which is nothing but 4. So I have to jump 4 steps. From 2 to I actually have to go to 6. But Aryan, 6 is not there. No worries. How about, see, the entire thing is circular, right? So how about I just write the entire thing again? Can't I write? Which means I have, okay, I have the 5 friends. So for sure, 5 is 0, 1, 2, 3, 4, right? It is up till here only. That is it. Now, as I have to go on to my next 4, which means 2 plus 4 is nothing but 6. Although I should have reached the index 6, but I cannot because it is circular. So basically what will happen is, if I just repeat the same stuff down, 0, 1, 2, 3, 4. So basically it is the same stuff which I have written the same step down. Now, because of this thing, it has to jump 4 steps. It can just simply jump from this 2 to actually this particular 6, which means if I just write 5, 6, 7, 8, 9 and so on and so forth, so it can just jump from this 2 to this 6, which is a 4 step ahead, which actually means it indirectly came back to 1, which means from this 2 it just want to jump at the location which is 4 steps ahead, but actually it will just come back from here itself. It is kind of a cycle which is being formed. And okay, so shall I write the entire array again? No. To replicate the same stuff, which means to replicate this entire stuff, that okay, I'm just going on further and not reaching my n bounds. N was 5, so I'm not reaching my n bounds, and I'm again coming back. So I can just simply do is, I am at I index, I have to do a jump of 2 into k. If I just simply do a by mod of n, then it will actually turn it back, because see, it has to reach 6. It has to reach 6. Then 6 mod 5 is nothing but 1. So basically it will try to turn it back to this location, which is nothing but the first index, and that is the friend which actually will receive the ball. So cool, the friend here, right here, will receive this ball. Now at the next step, which means here it has landed. Cool. Now no worries, it again has to jump. Now the jump will be of size what? Size what? 3 into k. K was 2, so the jump is of size 6. It has to again jump. Now jump up till what? I am at index 6. I have to make a jump of 3 into k, which is nothing but 6. So ultimately I have to jump 7. From 1, I have to reach the index 7. But I don't have it. So just simply by mod of 5, I will reach the index 2. So basically, after doing a jump entirely, it will again come back to this particular 2. You saw one thing. 1 was already, which means the number with the friend with the index 2 was already visited. And he got visited again. Because 1 was actually there, which means it was already visited, and it got visited again. That is the reason I can simply say, okay, the game has been ended. Cool. All these friends are good. They are having fun. While these 2 friends are remaining, which never got the ball, and the game ended. So I have to return these 2 friends as my answer, which is nothing but at index 3 and at index 4. But as we know, the friends are numbered from 1. Cool. It is the first friend. It is numbering from 1. And I have the indexing based on 0. So it is index 3, index 4. Index 3 represent 4th friend. Index 4 represent 5th friend. So I will just say, okay, it is the 4th and the 5th friend, and that is my answer. It is how you solve these kind of problems, that okay, if you have to perform a cyclic function, then you just take an array and try to perform that cyclic function again and again, and you might have one question, Aryan, how would I know that up till when this cycle will go on? Maybe it can go infinite. I'll say no, it will only go up till n. Why? Because every time the cycle you opt to go at, it should be unvisited. And if it is unvisited, because see, it has entirely n places that it can visit, right? And for sure at every step, one place is being visited, which means one unvisited place is being visited. And although if the visited place is being visited, then the game ends. So for sure, the entire loop, which means going on, it can at max go up till n steps, because after that, for sure, it will just break down the loop and for sure your answer will end. So the complexity is nothing but O of n only. That's it. And as n is very small. That is how you can actually replicate this. So make sure in future, if you have anything like that of cycle, replicate that in the form of an array. And to move to the next steps, you just from I index, I just move on the k steps ahead. So I plus k, but it is the bound, which means bound is by n. So I plus k mod n, and that will be your new location you will land on after jumping k steps from that ith location. And that is all you have to do. Basically, you will just keep that visited array, and as soon as a new element visited, you will just break down from the loop, and ultimately you will just check again what all numbers were unvisited, and you will just find the answer for that. Now, this is the first contest in which so basically, if you guys have got this part, and for sure if you guys had not known that how to what this cyclist stuff is doing, or how to handle this stuff, then please do smash that like button. And for sure, okay, we have 19 folks down here. Can we reach to 20 likes? That would be great for sure, because okay, we are learning something new in the contest. Although the problem is very easy, it can be solved by many ways. The constraints are pretty low, but we solved some different way that will be actually very useful in our upcoming harder problems. So yeah, can we actually reach to 20 likes? But meanwhile, I will just read the comments down. Suyash, we had done. Shalini, fourth, I knew that but could not code. Time was up and atak gaye the. No worries. Question 2, you cannot get wrong if you have studied digital electronics. Lol. Yeah, correct. If bit masking is done, or you have just tried the concept of bit manipulation and stuff, then for sure, question 2 getting wrong, there's a very less chance. Or basically, if you had done the problems, and for sure we saw many questions of bit manipulation and stuff, if you have just tried that will be easy to solve the question 2. It was straight ahead. You have to do this, and you can just solve it. That is for question 2. Ranjay Raghav, imagine doing coding after studying in digital electronics. That was a nice one. Ragini, it should be from 1 to 5 and not from 0 to 5. Yeah, correct. So basically I had from 1 to 5. So basically the numbers are from 1 to 5, but indexing is from 0 to 4. That is the reason I just modified that, because it was 5. So I just have to take it from 0 to 4, which actually represent the numbers from 1 to 5 itself. Hey Aryan, solve the fourth question, bro. That we will do. MS Darshan is back. Cool. Hi MS Darshan. I could not see you in the last stream. I solved all the 4 without any WA within 55 minutes, bro. That is cool. Abdul Nasir too, cool. No worries, Abdul. We will actually see the rest of the questions. This is my first contest in which I solved 4 questions. That is amazing. Empire Gaming. Yes, Niklo BC yahan se. Cool. No worries. That is a timestamp. We'll actually go on to it. Me too. @Empire Gaming. Q data structure, we can actually use any stuff we want. I was not able to solve the second question. No worries, we will actually go on to second question very soon. But yeah, before that, we have some folks down here. We will just quickly see the code of question number 1. It was pretty simple. I just have this visited array, which I will actually move on cyclically. And as we start on from the first, which means the 0th, I have my indexing from 0 to n-1. That is the reason I just put this first guy, it get the ball, so visited is for sure 1 for him, and then I'll just keep on current number If I am at the current location, what is the current location I am at? I am currently at the index 0, so it is for that current. Count is, I just make sure, okay, next time if my k is gonna be increased, which means multiplied by 2, right? And then nk is just the new k. I just say, okay, new k is nothing but k into 2, which means k into that count, and the count will increase, the new k will increase for sure. That is the reason how my new k, which means nk, will actually be go on increasing by k into the count stuff. If that same stuff is visited already, then I'll just break, because for sure if it is already visited, then I am again landing onto that current location, and if I am again landing onto that current location, just break it down, because ultimately my game has ended. Else I will just visit that location because I am landing onto that for the first time, right? Cool. Then as the loop goes, it will only end when that location which is already visited, it visits that same location again. Then ultimately I just go on and check what all numbers were unvisited, what all indexes were unvisited, and that index 3 will represent my fourth friend. That is the reason I will just write I plus 1 in actually my answer, and I will just push back my answer and return my answer. That is for the first question. And let's now quickly jump on to the second problem itself. But before that, can we reach 25 likes? That would be great. Great. Cool. Second one, it's actually a good question, actually good one. But for this, you should be in bit manipulations, as soon as you see or hear and, zor, or, your eyes, ears, everything should just stand up and just think in the bitwise form or the standard code wise form. As in the last live stream also, which was yesterday itself, I also told that if let's say and comes in, so one thing which for sure comes in my mind is that, okay, and is there, which means and a bit can only be set only when both the bits are 1. It is a thing which comes in for and. Oh, great. As you can see, the light is gone, everything is gone, and okay, but still the audio is fine, the video is fine, the light is not here. I'll just quickly can connect with the UPS, although the stream will for sure go on. Yeah, it is going on, but still let me, yeah, for sure light came back, but yeah, as light gone, but still the stream was not disturbed. It was because of the UPS, lovely UPS. The unboxing is coming today on our channel, so it's not actually unboxing, it's just a fun stuff I did while doing unboxing, and it's a very pathetic unboxing for sure. Don't watch it at all. I'm just posting it because I just asked my editor to actually edit it and do it, so it is being edited, so I'm just posting that stuff, but it's actually not at all a good thing to watch that. But yeah, cool. Let's go on to this problem. I was just saying that, okay, if we just see and, then first thing which comes to in my mind is, okay, I have to apply AND operation. So the bit can only be set if both the bits are 1, right? If any of the bits is 0, for sure the answer is 0. That should come for sure in my mind as soon as I read AND. For OR, I should see, okay, the bit can be set if any of the bit is 1. So one thing is 1. If it is only both ways 0, so it should come as 0. For XOR, it should come in as, firstly, XOR of any number with itself is actually, which means XOR of any number with a 0 is actually that number itself, and XOR of that number with itself is actually a 0. So basically, these 3 steps, these 3 basic things, it should come in your mind automatically as soon as you read AND or XOR. So as soon as you read XOR, these 2 operations, these 2 basic operations should for sure stand alone, come at your mind at a point that 0 XOR that number is always that number, and A XOR A itself, which means XOR of that number itself is actually a 0. It should come in your mind ASAP. Now cool. Okay, assuming that you have this knowledge priorly, and if you don't, now you have this knowledge. Now let's read the problem. We have not yet read the problem. Is that okay? One thing which I have in my mind is this thing. Now we'll actually start reading the problem itself. As soon as I hear XOR, it should come in my mind for sure. Cool. Now let's see the problem itself. I will not erase this XOR part. It's actually useful, but yeah, let's erase this AND part. But yeah, for sure in future for AND and OR, just remember this trick. But yeah, meanwhile, if the folks are watching, can we just smash that baby with a 25 likes? We can actually reach that, right? Cool. Moving on to this. a zero index integer array called as derived with length n, cool, is derived by computing the bitwise XOR of adjacent elements of the binary array as original. Cool. So basically I have an original array, and let's say I just make my original array as here. I have this original array, let's say having A1, A2, A3, and so on. I have made another array called as derived, which is nothing but A1 XOR A2 as this first location, A2 XOR A3 as this second location, and so on and so forth. Like this, right? Cool. Of length n. Now, specifically for each index I in the range from 0 to n minus 1, which means I will just keep on doing that same stuff. Now you'll ask, Aryan, what about the last element, which means it will be something like an minus 1 up till an. And for this thing, it will have the at the last location. Now, what will be the last? Because you said that, okay, the derived is of length n. I could see the pairs are being formed, but what about the last one? For the last one, I will actually do a XOR of an XOR a0, which means back to the first number itself, or I should write a1 as I want. That is what I have to do for the last number to obtain the XOR. Now, cool, you got to know, okay, what is original array and what is the derived array? Original array is we have to find, derived array is we are given. Cool. Now, specifically just, okay, explaining the same stuff again and again what I showed you above, sorry. That what we have is specifically for each index I in the range from 0 to n minus 1, cool, because indexing is for sure from 0 to n minus 1. Then if I is n minus 1, as I showed you that if I just land on the last index, then for the last index it is the XOR of the last number and the first number, while for the other numbers it is just the next number. So basically for the derived of I, where I is the last number, it is nothing but original of I, which is the last number and the first number, XOR. While for the other indexes, it is nothing but I and I plus 1. As I showed you that, okay, for these two, the XOR is here. For these two, the XOR is here. And for these two, the XOR is here. For the last number, it is nothing but an XOR a1, which is nothing but the last number and the first number. Now, what we are given is, we are given an array called as derived. Your task is to determine whether there exists a valid array originals or not. That could have formed derived. If it is, then we have to return a true, else false. So basically it is just saying, okay, valid binary array as originals. Now how I solved it for any array whatsoever. So basically I solved it for any array, not necessarily binary. It can be any array, zeros or any number, other number also. We can actually have it. So basically it is given that, okay, we are having a array of derived as a binary array itself, but what I had a solution of, and it is valid for the solution itself, is that maybe you have any array, let's say 4, 5, 6, and so on and so forth. Then if you just make the binary, and if you want to make, if it is, let's say, the array which is derived, and you want to make the original array, then still you can make the answer for it. That is one thing which we are gonna see the solution of, which actually will for sure contain this also, because it is the normal standard stuff, which is ones and zeros. Got it so far? Cool. But before that, it is just one more like, can we reach 25 likes? We can, right? Cool, we can. Before I just close my eyes, we should be able to. But yeah, just joking. Cool. Now, what actually, you know, okay, it is entirely given as a binary array, but we can actually solve this is not for a binary array also, which means the number are 4, 5 or something like this. Then also we can solve this standard stuff, because it's just simply a XOR operation which can actually be performed on any number. To make it easier, they gave it as a 0 or 1, because for sure, you know, 0 XOR 0 is what? It's 0. 1 XOR 1 is nothing but 0. 0. 1 XOR 0 is nothing but 1. 0 XOR 1 is 1. That is the reason they just gave you this stuff, that okay, maybe with this 4 operation you can do it, but actually we will see in the very actually good solution for this, where actually the number not necessarily need to be binary. Now that could have been formed derived, return true if there exists a such original array, or we have to return a false. Cool. Binary array, it contains number from 0 to 1. Cool, and no worries. Now let's actually see. Okay, we just see all these things are from 1 and 0, but actually we are going to see for what? For a natural, for a generic array which is A1, A2 up till an, like this. For simplicity, let's keep a0, a1 up till an minus 1. Cool. Now let me make it as derived array. Derived array, let me make it as, okay, cool, a0, a1, a2 and a3. Let's keep the example short, where I have 4 elements. Now my task is, can I make an original array? Can I make an original array as something where I have these 4 numbers written down here? Now for sure, one thing I know, whatsoever will come here, it's XOR. Let's say here it comes x and y. Let's imagine x and y XOR is nothing but a0, which means I am still confused what I will put as x and what I will put as y. Maybe if I can make one thing as constant, I can start making my array itself, which means I have to just try to make my original array, and at last I will just try to specify its validity by saying, okay, its XOR should actually be equal to this bottom array. Ultimately my aim is to make any original array, right? Any original array, which means I can put any number whatsoever. Ultimately, after putting a number, I just want to specify the validity. Okay, that original array should be valid. So what I will do is, I can see x XOR y should be equal to a of 0. It's still confusing. Okay, what to put in x, what to put in y. So what I will do is, I will put initially as a 0, because it is a very good number. As we saw that 0 XOR any number is actually that number itself. So I specifically choose a 0 because of its universal applicability, that it can be gone anywhere in the XOR and it won't affect my answer. That is the reason I just choose a 0 for my actual initial number. Now what will happen with this? The thing which will happen with this is, because of this stuff, I know 0 XOR y needs to be what? A0. And we also know that 0 XOR y is nothing but y itself. So as we saw above, right, 0 XOR y is y itself. Now because of this, my y should be a0. So with this, I found out my first, which means my second element of my original arrays should be a0. Cool. Now if I just wrote my a0 as here, and I want both of them should have a XOR as a1. So basically, let's assume, okay, it is y now. Now because of this y, what I can easily write the stuff down is a XOR a0 XOR y should be actually a1. Now as we also know the property of this, and see, what I want to find out is y itself, right? So I want to find y. I know this property itself, that repeating that same number, I get the XOR as 0. Now because of this property, I can just do a XOR both sides with a0, and then ultimately this a0 XOR a0 will become a 0, and 0 XOR y will become a y. Ultimately y will become a a1 XOR a0, which means, okay, cool, my y became a a1 XOR a0. Right, now again what will happen is, these two XORs actually, like, again say it as y, so these two XORs should give me as a2, which means a1 XOR a0 XOR y should be giving me a2. Now again I have to find y, so again do a XOR with this stuff both sides. I will just remove this stuff and will just reach this stuff a here. So basically y will again become a nothing but a2 XOR a1 XOR a0. Now okay, I have reached the last pair. But okay, which means I have, by my capability, by putting just one number, I have made this entire array, entire original array. Now I can't modify this array. I have to check its validity now, which means, is this valid? Is this array which I have made right now, is this valid? Which means all these numbers are checked, but except the last number. I have not checked the last number yet. Now let's check the last number, which means I have made the array, making the array is done. Now checking the validity part is the problem itself. Now what I will do is, whatsoever I got in the last number I have found, which means I have formed the original array, right? So whatsoever last number which I have formed, I will do the XOR of that with 0, and for sure it's a 0. So number, let's say this number is y XOR 0 is nothing but y itself, right? So the last number formed should be equal to my last number of derived. If it is the case, I will just say, yeah, it is valid, and with this stuff I can easily say, okay, I have actually made my original array which can actually result in a derived array, and that is valid because you saw above, right? A0, A1, A2, which means all the numbers which were not including the last number, all the numbers except that were actually made valid for my above array. Because of all these numbers, I made all these numbers, right? Thus, ultimately, I just have to verify that last number formed in my original array should be equal to my derived array ka last number, and I would be good to go to say, okay, that is actually a perfect thing. That is how you have to solve this problem, which means ultimately you will just place a 0 at the first step. Then you, because of this derived array, you will just keep on making your original array, keep on making your original array, keep on making your original array, and ultimately your original array will be made up till the n minus 2 numbers, which means n minus 1 numbers are completed, your original array is completed. Now, your last element of derived is still left to actually being used to verify. So lastly, what you would do is you will just check, okay, why XOR the first number, and the first number we have placed as 0 because of its universal applicability, and that's the reason why XOR y should be equal to my last number, which is nothing but a3 or a of n minus 1, whatsoever you want to say, and that if it is equal, it is true, it is good. If it is not, then sorry, that can't be done. If you guys have got it, then just smash that baby like button. Let's reach to one more, just one more, and we will reach 30. And for sure, let's quickly jump onto the code. After that, we will go on to the comments. We'll actually go on to the comments soon. What I'm doing, cool. As you will see, it's pretty simple. I will try to make my original array. I have my derived array size. Firstly, I just wrote this base condition. Let's say if n is 1 and derived is 0. Why this base condition? I'll just show. If I just go back onto my tablet, see, if you have just one number, right? If you have just one number, array yaar, chalna. Array bhai. Yeah, if you have the original array and original array has only one number, let's say the number is 7 or any number whatsoever. Let's say the number is A. So if you just find the what was the array name? Derived array. If you find the derived array, it will be nothing but that the first number XOR last number, which means A XOR A. Which means if the number is only 1, for sure your derived answer should be 0. A XOR is always a 0, which means XORing with the same number is always a 0. So that is one base case. Okay, if you have just one number, for sure your derived should actually be a 0. If it is not, if it is 1, you are gone, or anything else, you are gone. Cool. So I will just place this simple condition that, okay, if my n is 1, which means I have only one element, so that my derived should be 0. If it is 0, I'm good. If it is not, which means n is still 1, which means I have still one number, but your derived is anything else. Although in this question it is 1, but let's say if it would have been anything else also, then also it is a false. That is what you will do for the first condition. Now you will try to make your original array. And as I showed you, original array's first element, which means the 0 index, will actually be placed as a 0. And the first index will actually be a derived of 0. As we saw above, as we saw that my original array's first number will be a 0, and the second number, which means original of 1, is nothing but a of 0, which means derived of 0. That is what we have to do, exactly same. If you just see, it is original of 1 is nothing but derived of 0. Now I will just keep on going from index 2 up till index n minus 1, and will try to make my original array by simply doing a XOR operation of, as I showed you how I am doing the operation. I am just simply doing a XOR operation of original of I minus 1, the last number, and the derived of I minus 1, which is the bottom one. So by this I will just get it, my origin of I, which is the new origin of I, which I have to expect based on this last derived of I. Cool. And by this ultimately I will be able to make my entire original array. Now lastly, I have to check the validity of that original array, which is nothing but original of n minus 1, XOR of original of 0. But this XOR, you will see, it is actually a 0 itself, so it doesn't matter as such, but it should be equal to the derived of n minus 1, which means the last number of derived one. If it is the case, return a true, else return a false. This code is not dependent upon 0 and 1, that is for sure. It is like to actually make this question easier, which means you don't have to think itna kuch, is just that 0 and 1, the 4 operations which I showed you, you can actually make it by that add stuff also, but I just showed you that how you can just get the stuff generalized and solve it a bit more higher level. That is what we actually saw in this problem. Cool. Before quickly moving on to the third question, we'll actually go on to the chat and see. But if you have got this second problem, then please, let's have it reach to 35 likes, and that would be great. But meanwhile, let's quickly go on to the comments. MS Karthik Darshan, 55. Okay, Q1 5 minutes, that's awesome. Q2 55. Q2 55. Okay, that's great, but still we can actually, because see, whenever we think of AND, OR and XOR, just quickly snap at the finger snap, just think of those 3 stuff which I showed you in the beginning. For the XOR operation, 0 XOR same number is actually the same number. A XOR A is actually a 0. Just quickly think these 2 steps and how, because it is very important for these XOR operations to think these 2. It's very important for XOR, and that would actually be able to solve your entire half of the problems for XOR. So it's the reason I showed you. Before even reading the problem itself, I just read the word XOR, and that came in my mind. Okay, these 2 operations would like not sure used or not, but came in my mind. It is what I'm saying. Cool. For question 3, 23, that's great. Question 4, 49. Considering you are watching the graph series, a bar graph series, that's exact same question in a slight other. Basically, if you just merge lecture 2 or 3 and lecture, I guess 11 or 12, then by just merging these 2 lectures, you can actually solve the 4 question very fast, maybe in 5 minutes or 3 minutes. It's actually very standard stuff. So yeah, by just our bar graph series, you would be able to solve that in 3-4 minutes, because actually it's very standard. I've actually spoken the same stuff in like the half part of the problem in lecture 3 or lecture 4, I'm not sure, and the half part of the problem, which means the complement part of the problem, in lecture 11 or lecture 9, I guess. So that is very much me too. Q data structure, that is working, we can solve. I'm not able to solve the second question. We have solved the second question. I have semester exam on, bro, so was occupied. Oh, no worries, MS Darshan, that is no worries at all. Priyanshu Singh, Manish Kumar, Q data structure, that is done. Okay, you can do anything with that. Priyanshu Singh, yeah, Priyanshu is back. Priyanshu was also yesterday also. Cool. I solved all 3 but did not get the intuition for the second. That's the reason I just showed the proper intuition for second, and how we can actually start building stuff for second. Ashish Pal, hi Aryan, hi Ashish. Obito Uchi, maybe if I'm correct, not sure. This contest was easy. I solved all the 4. Yeah, this contest was actually easy. I started this contest around 48 minutes because I was recording this our question, which was today. If you have not watched today's problem of Leetcode, it's actually a very good problem of AP plus bit masking. No matter what, if you are a beginner, not intermediate, higher level, no matter what, even if you are just learning the language itself, I highly recommend to just go and watch that problem. In that you actually see that what is the actually use of masking and stuff. Masking and stuff we have seen in video editing, but actually in programming, masking is also used, and that you will see greatly by that example. So I will highly recommend just go and watch that video after the stream, because for sure the stream will actually have some great learnings which you will learn. So for sure, watching the stream is actually helpful. Not saying if you have solved the problem, still I highly recommend other folks to go and look at the other solution of what approach they took and how that approach they can use. Because see, problem 2 can easily be solved by a simple the 4 operations of XOR, but still I showed you a very naive or very standard or very common approach which can be implemented in various other problems of that XOR also. That is the benefit of actually watching. I'm not saying to watch my only streams. Also go and look Leetcode, pay others ka solution also. That is also very beneficial, because it will hardly take a minute or so to actually look at others. Okay, if he has used the same stuff as what I have used. If not, then just go and look at it. Cool. So, but still, Obito, that is fine. Prince Pawar, hi, Prince. Hi, Prince. We have met before, I guess. Aryan bro, give some tips and tricks on how to practice to solve these type of questions. We actually have this tips and tricks session at the end, but for now we'll solve those questions. But for sure, you can just remind me in the end to actually highlight this stuff. But you can actually go in the end. 16 lines didn't get. 16th line. What was the 16th line? 16. So basically this original of I, as I showed you, I will quickly show you. This is, it's nothing but original of I minus 1, XOR derived of I. If I just go back in the, okay, sorry, my tablet was not visible. So basically line 16 was original of I is nothing but original of I minus 1, XOR of derived of I. As we saw also earlier in the code that our original of I, it is original of I. It is nothing but original of I minus 1, XOR of derived of I minus 1. You saw above, right? It is A1 XOR A0, which means A1 XOR A0. For this original of I, it is nothing but original of I minus 1, which means A1 XOR A0, XOR with A2. That is what you formed here. That is to find the original, to find the original of this number I just did a XOR of the last number, and I just actually proved that. Okay, how is it actually possible to simply do a XOR? Because it just boils down to a simple operation of these two numbers, and you will get the original of I value. That is, I hope that I solved your doubt, Ashish. Oh, not able to see code. Oh yeah, got it. Thanks. Cool. Suyash, there is any other way to generate original array? There can be many ways. We can try multiple stuff as starting one and just get it out. But the most easiest one to actually go on is the number 0. And for sure, the original array should be actually being computed, because see, original array, it can have multiple values, but getting from derived to original, I just want one way out. One way out, I can just use every of my derived elements and get the original array back. Just one way, that every derived element is being used, and that how every derived element is being used, I just did a one way to you. Suyash, is there any other? Yeah, that is done. Sara Gupta, 4-year BTech mining engineering. What a channel name. What about fourth question? We will do that fourth question very quickly. Let's go on and start with the problem 3 initially, but before that, can we just reach to the 40 likes? Before that, Kuntia or Kantia, I'm not sure. XOR all elements in an array. If it is 0, return true, else return false. XOR elements in an array, return true, return 0. That also can be possible if we just go and have a look, because ultimately this stuff, if you just go and look at this stuff, it is nothing but A1 XOR A2 XOR A3 and this particular thing, which means I am ultimately having a last check at A0 XOR A1 XOR A2. It should be equal to A3. If I do a XOR of A3 both sides, I will get a 0 here, which means if I just do a A0 XOR A1 XOR A2 XOR A3, I will get a 0. So basically, it is one thing which is derived. Okay, A0, A1, A2, A3. I just did a XOR of all the elements and I got a 0. So basically, how this thing is derived is by this stuff only. Indirectly, we can have many ways to write the same stuff down. It is one other way. I can ultimately have a check if all the elements have a XOR as 0. Okay, it is actually a good stuff. But actually indirectly at the back end, what was happening was ultimately the last number became as this and it needs to be equal as this. That's the reason I just made a XOR both sides and I actually did the answer. I hope that you guys got it. Just Ajay. Okay, cool. Just Ajay. Yes, got it. Second question. He ajeeb tha, baki easy the. Yeah, that is correct. But depends upon the fourth question. In fourth question, I used DSU. If you had watched our bar graph series or other lecture of a graph series, I have entirely said when it's a problem of a very basic component, there is no point of using a DSU in that basic component problems. Basic component problems are solved by a simple DFS traversal. It's very short, very fast to write. I can write the same stuff in 3 minutes down. To implement the DSU, it will actually, to implement itself, it will actually take 5 minutes. So it's highly recommended when the DSU is not needed. We should not think of DSUs. So basically thinking of DSUs you have to change. Okay, when I have, because see, every problem of components can be solved by this DSU, but it is just way too extra to solve, to use DSU for this very basic problems. Simple component stuff, which means simple DFS traversal, can actually solve your problem of DSU or of components. But yeah, before that, we cycle in DFS, that is correct. Cool. Before that, we'll just move on to the problem number 3. But before that, if you guys have not liked it, then what are you waiting for? We have done the 4th question by just beautiful intuition method. Let's move on to the 3rd question. Here it says that maximum number of moves in a grid, which means I am having a zero index integer array of size m cross n matrix grid consisting of positive integers only. Cool. We can start at any cell in the first column. Mark my words. I can start from any cell in the first column, which means any cell I can start from in the first column. Remember this. Any cell in the first column. Cool. Then what we have to do is traverse the grid in the following way. How is the following way? I can move on to row from the cell row comma C, which means if I am at the cell row comma C, I can move to row -1 comma C plus 1, which is the above and the next row, or the just front row, which is nothing but R plus 1 comma C, or the just bottom right row, which is nothing but R plus 1 comma C plus 1. I can move from this R comma C to these 3 locations, but only when such that the value of the cell you move on should be strictly bigger than the value which you have currently in. Which means if I am moving from, let's say, here to here, so the value here, let's say x, should be actually y should be actually strictly more than x. Then only I can move from x to y. That's pretty much it with this. Now, by seeing the constraints, I actually can see, okay, I have to solve this problem in O of m into n only, which is nothing but O of 1e5. So I can't go on. So basically, first thing which for sure comes in my mind is, let's try with the first number and we'll try to go on how much far I can reach. Then I will just try to go on with the second number and I will try to go on, okay, how far I can reach. I can't reach anywhere. Then I will try with the next number. I will see how far I can reach. Then I will just reach up till here. Now I will try for the 4th number and see how far I will reach. I can't reach anywhere. So basically by this, I will just go on to every of those row and I will just see, okay, how far I can reach. And to know how far I can reach, I will just go on in the array, like this. One simple standard way is, you go on to every column. See, I will just show you 2 ways. Both are actually working in this problem. One very basic thing is, I actually go on to every row. And from that every row, which means I'm starting with this first row, which means the first cell. Cool. I will just try to go on to whatsoever number is possible. I will just go on, try to go here. Next, I'll try to go here. But the caveat in this is that from a location, right, you have 3 locations. 3 locations. From this other location also, you will have 3 locations. Let's say this again will have 3 locations. So now, although it will overlap, although you will say, okay, Aryan, this location will actually have, let's say if this goes on, then it will have again 3 locations different, 3 locations different, 3 locations different. So basically the number of locations you are actually hopping on would actually be increased. So you can't just go, okay, I will just try with every number, every whole cell, and I will just try to go through all these 3 locations, and then from all the 3 locations again, I'll just try to go on every other 3 locations, and so on and so forth. It will actually get your complexity a bit high because you can't afford that much. So basically what I wanted is, I can't go on the entire array, which is O of m into n, for every row, which is O of, let's say I have n rows. I can't make this stuff happen. As simple as that, right? Which means I can't have n into m cross n. I can't have. Although by constraints, if you just go and look, it is 1e8. It can be possible, cannot be, not sure if how badly you write this code or how good you write this code, but still we can actually make the same stuff happen. Why to actually go on to O of n? Why to actually go on to every row again and again? Which means if I'm starting with this row and this row and this row and this row, I can start with all the rows parallelly. No, why can't I start parallelly? Let's see how we'll do that. Which means I just got to know, okay, one option is I can start from these every of these n rows, and for every of these rows, which means every of these cells, I have m cross n options to actually see, okay, if I can reach, how far I can reach. One thing is this. Next thing which comes in our mind is, okay, let's optimize this further. How we will optimize this further? Let's erase this part. The part we will optimize is nothing but, rather than going on to every row again and again, which means I just go on to first and second and third and fourth, let's start with all the rows parallelly. Cool. Then I will just go and visit every of these columns. Next column I can visit, which means from this 2, let's keep it as this, another array. Cool. Now this I will just keep at, okay, if I can visit that or not. If I can visit that or not. Cool. From this 2, I can visit a 4, and for sure I can't go above, so I will just have a check, okay, from I comma j, what is the next valid? My next location, it can be I minus 1 comma j plus 1. I have I minus 1 comma j plus 1. I have I comma j plus 1. I have I plus 1 comma j plus 1. So I will just check, okay, if these cells are actually valid or not. It is one function which I will make for sure. But before that, what I have to do is, okay, if I just go on from one number to the next number, from this number I can go on to the next number, okay, I will just mark, okay, it can be visited. The cell right here, it can be visited. Cool. I just mark a 1. It can be visited. Cool. It can be visited. Okay. Oh, so for sure. For this 2 we saw, I can go on to 4, can go on to 4 also. So basically for this 2, this number can be visited for sure. Cool. Now for this next 5, may I visit a 4? I cannot. It is less. I can visit a 4. I cannot. I can visit a 4. I cannot. So for this 4, nothing is affected. Cool. For this 3, I can actually go on to 4. Yeah, I can. For sure. Okay. It is already visited. So for sure, I can visit that stuff with 3 also. No worries at all. I can just have to visit that cell. From 3, I can actually go on to 4. Yeah, I can visit this cell also. That is also no worries. From 3, I can go to 9 also. I can visit this cell also. That is also no worries. So basically what we saw is, from this starter cells, I can actually reach on to the next cell. Cool. Now, for the last cell which is remaining, for the number 10, can I reach to 4? Nah. Can I reach to 9? Nah. So basically, cool. No worries. From these cells, I just got to know one thing. I can reach to the next cells like this. Now, I will repeat the same stuff for the next cells itself, which means from this 4, I will just try to reach to 3 and 9. Is it possible to reach 3? No, it is shorter. I can reach 9, but it's okay. I can reach 9, provided I am coming from, provided, okay, it is 4, but also it is 1. If it would have been a 0, I would have never counted this 4 to actually go on to my 1. Understanding why? Because it just shows me I have came from 2 and then I am coming to actually 9. Thus, it is actually showing, okay, 1. If it is 1, if you saw, it was actually a blue one, which means it was made. It was possible to come from back. If it is yes, then only I will just check, okay, if it is actually required to go from this 4 to next location. If it was 1, which means I can actually reach 4. I can actually reach 4. Now I will just check, okay, try to reach other number, which is 9. Yeah, I can reach 9. If it would have been a 0, I would have never opted to just look at it even, because I cannot visit it, so why to look at it? As simple as that. Good, cool. It was visited, so I just marked it as 1. Now because of, sorry, it was just a blue one. Because of this visited 4, I can visit my 9 only, so it is a 1 right here. Now because of the 4 next one, which is 4 right here, I can't visit a 3 for sure. I can visit a 9, and it's already 1, so I just make it a 1. It is already 1, so no worries at all. I can't visit a 2. Cool, no worries. From this 4 itself, I can visit a 9. It's already visited. I can visit a 2. No, I cannot. I can visit a 13. Yeah, I can. So for sure it is visited. Considering the fact, always make sure that this number was already visited. It's the reason I am checking that, okay, now I have to go from this number next or not. Ultimately in the last, it is the number 9. I can go to 2. No, I cannot. I can go to 3. Yeah, I can. So for sure, market has visited, but it was already visited, so no worries at all. Ultimately, from these two numbers, I can only check. Understand? From these two, I will just go on. I will go on from 3. Shall I even try to see 3? Shall I even try to see the 3? No, I will not try. Because what? Because why? Because 3 was never contributing. 3, I never came at 3 itself. So how can I contribute by 3? Cool, I will just check with 9. Is 9 contributing? 5 or 3? No. 11? Yeah. So for sure, add a 1 here. Now with this 2, is it contributing? 3? Yeah, it is. But I never landed on 2. You saw above, right? I never landed on 2. That's the reason I'll just put a 1 only here. For 13, I can reach 11. No, I cannot. For 15, I can reach. Yeah, for sure I can reach. So for sure 1 here. Ultimately, what I can do is I will simply go on, and it is how I will do. Now, ultimately, to find the answer, I will just keep on going from the left, which means I will start from the index 1, and I will see, okay, if I have this thing as 1, okay, if any of this value has 1, cool, just increment my count pointer, which means I can reach my first row, because I just have to bring the answer, okay, how far I can actually move, which means how far, which means how far the column I can actually reach. If anyone is 1, I am good. I'm good. I can reach the first row. If anyone is 1, I can reach the second column also. I can reach the third column also. So that's the reason answer is 3. But while in the case, if anyone would have been 0, then you would have considered, okay, if anyone, let's say this entire row would have been only empty, then no way the entire stuff outside would have been any values as such, which means entire other thing, the right part, would also be for sure empty. That is the reason I will just break it down and I will just say, okay, the count is only 1. That is how we can solve this problem very, very easily. Although there can be multiple ways, but it is one of the DP kind of way, because if you had studied DP, but it's not actually DP thing, but it's just that, okay, for this one, I can just see, okay, if I can reach these location, then good. I can just mark them as visited, and then I will just try to go on from those location to from those location to other locations if I can reach. That is all we have to do in this problem. If you guys have got the logic, and for sure, if we just try the same stuff down, I cannot reach from 3 to any location. I cannot reach from 2 to any location. I cannot reach from 1 to any location. For sure, the answer itself is ended here. It is all entirely zeros. That is the reason it will just start from 0 itself, and it just give me a 0. That is how we will solve this problem in nothing but O of m into n. I hope that you guys got it. If yes, then do smash the like button. Let's aim to reach 45, and that would be great. For these 23 folks watching, lovely folks, I love you guys. But still, considering you are also studying and bringing that up, for the good luck of you, just having some psychological effect, maybe you just do good in the contest if you just like it. For sure, like it for that reason. But yeah, no jokes apart, if you have any doubts for this thing, the way we actually went onto this problem, just let me know down below, and we will be very happy to actually solve your doubts. Before that, let's me quickly go on to the comments. Ashish Pal, we got 40 likes. Ho gaya. Oh, cool. Let's reach to 45. No. In down is -101. That it is completely actually what you say. It's completely actually fine to actually make, because see, if we want to move to directions, we can actually have a -101 the direction array, and that is actually a better way to actually solve it. But when the directions are less, which means 3 or 4, we can actually write the directions down also. That is actually also fine. Column is always +1. That is also correct. DP 2D DP, we can actually say it as a DP, but DP as such is not that much, like I can name it as a DP itself, but that is the case, right? Name it a DP or not, still the concept, the backend concept being applied is actually applied on the DP on grids. That is the reason it's actually, we can say it as a DP, but actually don't get scared by, okay, I have never heard or learned of DP. I just showed you that it was not exactly very hard as such of DP. It's a simple saying, okay, if I have visited some stuff, and now I can visit the other stuff by just considering the fact, okay, I have visited that. Now from that visited location, I can visit other location also. Cool. Instead of filling DP with ones, we can also fill it with the cell or with the column number itself. And to check if the cell is not reachable, we can also insert the DP -1. That is also correct. Yes, got it. Bhai, which tablet are you using? See, are you saying I am using this Samsung S6 Lite? In all the videos in the description down below, if you just go watch and our last Leetcode video, which means that video we posted today, or any video in general, if you just go in the description, I have given all the links down of all this stuff. Camera, lights, this light, that light, my monitor, my tablet, my keyboard, my mouse, my my pen tablets, like right now I'm using this Samsung ka, because I can't afford Apple wala right now. But earlier I used to use my XP pen ka, in which you used to write by that pad only, and the screen was not there. But right now the screen is there. That is the reason I like this stuff. If you can just see, I just like this stuff. But yeah, if you want to just have a look at it or even buy it, anything, it will just support us if you just buy from our links. The links will be down below. I guess the links should be down below. Not sure if it is in this live stream or not. Yeah, the links are down below if you just want to have a check. Just is in the starting itself, the products, everything whatsoever I use is actually down below itself. So if you want to start your coding journey, just educating other folks, because I always encourage that the more you explain, the more you will get better at explaining stuff. So for sure, because see, in interview you actually have to explain it to the interviewer. So if you want to practice that explaining part, you can just make your own YouTube channel and just try explaining the same stuff. Maybe if you are just afraid of the camera and stuff, no worries, just record that stuff, just explain to yourself, or let's imagine you're explaining to your younger brother and explain in that way. By that, what will happen is you will just get better and better at explaining. It's not a one-day thing. It takes years to actually get better at what you explain and how you explain and what you think, okay, will get in other person's mind. So if you want to, because see, in interviews, I'm not saying to actually go and like buy all this stuff. It's not necessary at all. Just write a pen paper down and try to explain that stuff. Maybe record that stuff by just explaining in that pen paper, or maybe in the OneNote, Notepad, any editor you can choose, anything you can choose. But try to explain into the camera, considering the fact that your younger brother, your lovely audience or anything is sitting just beside the camera and you want them to understand. That is how you will get good at explaining stuff, which will actually help you in interviews. Because interview is, because see, your coding, yes, how good you are at coding is actually half of that is tested in your OA itself. To actually see that how good you can communicate, how good you can actually express your ideas, it's actually solved in the interviews itself. So it's actually highly recommended that you just solve that part in interviews itself, by just practicing yourself. Like it just takes half an hour or 1 hour to just record one video down. Post it or not, it's your option, but just try to do it. By that, if you guys are liking it, then please, can we reach to 45 likes, right? Yeah. इतना तो बनता है ना, इतना तो बनता है, for sure बनता है. Cool. Ayush bhai, I guess Ayush, I solved your query. आशीष पाल, मैं always आपका डिस्कशन देखूंगा, अगर सॉल्व भी हो गया या न्यू इंट्यूशन मिलता है आपका डिस्कशन देख के. लव यू फ्रॉम मुंबई. Cool आशीष, love you. Yeah, and that is highly recommended that even if you solve it, then it's recommended that still just have a quick, I'm not saying to watch the entire video. You can go and look at my code itself. Just go look at my last submissions and look at the code itself. If I have done something new which you have not, then you can just go and come back and look at the video itself. But still, just try to always look at others' code for sure. Ayush Singh, what do you prefer, tablet or paper notebook? Paper notebook. So basically, while doing the contest itself, if you just go and see, it is, I'll just show. Okay, for this today's contest, I've never used it, but if you can see, it is the last problem which I did yesterday. For this, if you can see, I just write everything down in my notebook itself. So it is how I just solve stuff down, that because in contest you cannot write on this stuff. So it is the reason I just have 2-3 notebooks in which I just write like this. I just make DPs and all that stuff. Like this, and just try to solve like this stuff. And for sure, please don't scold me by this saying I just use way too much space. Yeah, I use way too much space because it's just free. All these notebooks are free. The pen also I use is also free for me. So for sure, I just try to use that because I just can't make very congested stuff while just writing and solving the code. That's the reason I just solve in my notebook itself, because it's fast. It's not as small, because see, it is way too big in comparison to the screen. That is the reason I just try to solve it there. Just Ajay brother, मेरे placement आ रहे हैं, पास में थोड़ा guidance चाहिए था. For sure we'll give that in the end. Just remind me in the end to give that stuff. Khush, not able to give the contest. Can I give virtual contest and see your videos later? For sure, it's highly recommended. If you are not able to give the contest, just go and give the virtual contest. And yeah, before that, yeah, can you just please like that? Yeah, let's reach on to 50 likes. Oh, cool. Thank you. Cool. Not able to give the virtual contest. Cool. If you're not able to give the contest, then for sure give the virtual contest, or maybe see. As I was recording the videos, the lecture of today, which means the hard lecture which you saw today of Leetcode, that I ended that recording at around 8:30ish, and by posting that it took around 8:45 or 8:50. I started a contest at 8:50. I did not give from my main ID itself, but still I gave that part because I wanted to know how fast, because see, the actual stress environment which you actually go through while giving the contest is actually what you needed. So for sure give the virtual contest itself. Not able to give the contest, how to improve communication skills like you. See, it's just by practice itself, like nothing I did much that, okay, it just gets improved. Just talking with camera, with people, actually real life people will actually get better in communication. That is exactly like coding. Just try it, just give time to it, you will get better at it. That's actually Khush. That is actually Ashish Pal, done 45 bro. Leetcode ka ID to de do please. It's Aryan_0077 if you want to go and check. भाई ऐसा कुछ है क्या, मैं अकेले ही 100 लाइक्स कर दूं आपका? होता तो भाई मैं ही कर देता, but still that is not we can do. But yeah, we actually have to go and look at the code of this problem 3. I hope that you guys have remembered the entire logic which we have used. We just simply go on, start from the first index itself, and then go on to every of those next numbers, which means firstly I have this is valid condition which will actually go and check if that location I and j is valid or not, which means it should be in the bounds of the grid. It is R is valid condition. But before that, if you guys can please reach to 50 likes, that would be great. I just legit say great. Then it is a max moves function which you have to implement. Firstly, I just went on and used my visited array, which will actually show me, okay, if that number, if that cell is actually visited or not. It is this visited array. Now I will go on every column wise, and every column wise I have to go on to every row. That is the reason I've started from the columns itself. So I'm going on to every column starting from the column 0 up till the column m-1. Then because you saw, right, for this column I can, okay, go here, like this I have to go. That is the reason I'm just going on from the column itself. And for every column I have to go at entire row. That is the reason I'm going on the entire row. See, my n are always rows, my m are always columns. So that is we have to make sure. Cool. Then I just firstly as the initial cell, which means the first column, the column at index 0, the 0th column, I can start from the every cell of the 0th column. That is the reason every cell, every row of the 0th column can be visited, because I am starting from that, right? It can be visited for sure, right? Yeah, cool. Then what I will do is I will just simply check, okay, if that cell I am going on, I am standing at the I comma j, I have to go at 3 locations: I minus 1 comma j plus 1, I comma j plus 1, and I plus 1 comma j plus 1. If these 3, which means if I have to go at these 3 locations, I check, okay, is that location, firstly, is that location valid location? Okay, if it is valid, then is that grid location more than the actual location I am moving on? I am moving from this I comma j to I plus 1, I minus 1 comma j plus 1. I am moving to some location, other location, it should be more than my existing location. Okay, I check that. And also make sure if I am moving from I comma j, then please that I comma j should also be visited, because if it is not, then it's of no point to go from that location to other location, as we saw here also in the code, as we saw above, that if it is not visited at all, where's my pen gone? If it is not visited at all, which means if it is 0, it's of no point to actually go to other locations. We can't. Only if it is 1, only then I can go on to other locations. That is what we have done in that case. Now I just repeat that same stuff for my entire other things also, which means I comma j plus 1 and I plus 1 comma j plus 1. Ultimately what will happen is, I just showed you that whatsoever I can visit the cells, it will just get values as 1, which means visited as 1. Then I'll just go on from the first column up till the last column, because ultimately I have to check, okay, how far in the columns I can go. Starting from the column 0, my answer 0 will actually store, okay, answer, what is the maximum number of the columns I can go actually. Then I will actually go on from my entire row, and we'll see, okay, if there is any 1 in this entire row or not, which means at a column, at a column, I'll go into the entire row and check, okay, is there anyone in this? If there is any 1, for sure, I would have reached this column. If there is anyone, I will just increase the count, okay, to check, okay, if there is anyone or not, if there is anyone or not. If there is anyone, then I can for sure say, okay, I can reach this column, which means if count is having some value, I can for sure reach this column. If I can for sure reach this column, that is the reason I'll just for sure say, okay, if count is having value, I can reach this column, I'll say I can reach this column. Else, if the count is 0, it is entirely a 0. It's good to break out, because if this row, if this column as j is 0, then for sure the rest of the other columns will also be for sure 0. So for sure break out and just return the answer, which is the columns I can. That is for the third question. I hope that you guys got it. Now let's move on to the last question. Before that, let's quickly jump on to the comments and quickly, yeah, before that, if you guys have not liked it, then let's move on and reach to 55 likes. That would be great, because we are just moving on very close to our last question. Just a quick chat read. I am from tier 4 or 5 college. Bhai, tier 4 क्या होता है यार? खुश, just अजय placement पे ध्यान दो. एक मिनट, I just go on above. Go ahead, सुंदर पिचाई से कराऊं बात आपके लिए. Great bro. Go ahead, आशीष भाई, go ahead. Cool, that was nice one. Are you saying, भाई मैं सर्विस बेस्ड कंपनी में काम कर रहा हूं, बट वहां मेरे को डेवलपमेंट नहीं मिल रहा. 1 year almost completed and I wanted to switch to a product based company. What should I do? Please help me. See, simply just what we can do is do Leetcode daily. And also, if you get time, then 1 virtual contest a day keeps unemployment away. So for sure, 1 virtual contest a day, and I should say, okay, 1 Leetcode contest a day. Sorry, 1 Leetcode problem a day keep unemployment away, or basically better companies near to you, hotter companies near to you. So for sure, 1 Leetcode question daily we have to do. That is one thing. If you get more time, then it's good to give 1 virtual contest also, if you get time. Although it's hard to find time with job, I know that part. So that is one thing which we can see. But yeah, 1 Leetcode problem we can actually solve daily. If I can make a video, why can't you solve 2, right? You can solve 2. So for sure we can solve the 1 Leetcode problem. It will actually keep unemployment away. So that is one thing which you have to make sure. Placement पे ध्यान दो भाई. आशीष पाल, just Ajay. Cool. I guess you guys are becoming friends in the chat itself. I'm not sure how, but yeah, that's great. Khush Mangal, I am from a tier 4-5 college. I work hard, then I will be able to crack any big company. See, firstly, college don't matter as such if you can actually work hard, because see, college is actually just give you a better exposure. But if you actually increase your skills, work harder, solve more problems, get better at problem solving, you can get the calls directly from the recruiters and all that stuff very easily. So basically college won't matter as such at that point of time. So for sure, just solve the problems, just get better at problem solving. Give more code forces also, if you get time also, that just try to give code forces also. I highly encourage that. Code chef also. And if you just have a very restricted amount of time, then maybe you can stick to Leetcode daily and also virtual contest of Leetcode. But yeah, that is pretty much a reflective of what you can expect in an interview and an honor assessment. आशीष पाल भाई, आप क्या कर रहे हो वैसे? भाई मैं रगड़ रहा हूँ. अरे मतलब I am a software development engineer at Goldman Sachs. If you don't know, you can just go and check my LinkedIn. That is there. मैं तो 3rd year ये खत्म होने आया है. Cool. Yeah, I just mostly know that many folks are just going on for the internships, maybe preparing for the internship season, all that stuff. So that is one thing for sure. But yeah, before that, if you can just please reach to 55 likes, that would be great if it is possible. for sure. That would be great. क्या भाई भाई जो आप करना चाहते हो, ये आशीष पाल एंड अजय आर जस्ट चैटिंग विद देमसेल्व्स आई गेस. क्या भाई सही है बताओ यार. तुम भी थर्ड ईयर में हो क्या आशीष पाल भाई? जस्ट अजय सही में सर. सही में यार. विच कॉलेज? मैं तो SRM से हूँ भाई. जस्ट अजय भाई सर्विस नंबर से नो से नाउ से. ओके, ओनली प्रॉब्लम सॉल्विंग इज इनफ फॉर स्विच. See, for switch, although I have talked with many folks, only problem solving is actually more than sufficient, but many people do self problem solving also. So basically, either you can be very good at problem solving, which means get very good at problem solving, which means very good, but usually it's impossible to get very good very fast, right? So one way is to actually balance all this stuff out, which means we can have a better projects, because we can't be very good, which means we can't be guardians or very much extreme level in like Leetcode or Codeforces or Codechef, which means we will be above average in problem solving, but for that above average also we have many folks in the line. That's the reason we actually have to balance that out with actually a project, a good achievement, all that stuff. Cool. I will just go on to the charts later. Let's quickly see the problem 4. That is also pretty easy. If you have watched our bar graph series, I have discussed the same stuff, I don't know, endless number of times. So that is one thing that for sure that will be helpful. How? The problem says that we have to count the complete components. One thing, count the number of components. This problem we have solved exactly endless number of times by simple DFS, right? Now if I say, if I can find the count of components as 5, now out of those 5 components, just make sure how many components are complete. We can just get, okay, I will just say out of those 5 components, 3 are complete. Our answer is 3. It was as simple as that. And if you don't know how to find the components in a problem, although I'm gonna show you in this problem in this video also, but it's actually better not to study these kind of stuff in contest, but actually in beginning itself. So you can just go and watch our bar graph series, where we have actually completely showed you how to find the components and to check which components are complete in the other lecture. So basically, if you just merge 2 lectures, you would be able to solve this problem. Now, moving on to the problem itself. But before that, can we reach to 55 likes, folks? Just quickly. That would be great. Basically, you are given an integer n, which is as simple as the nodes. There's an undirected graph, which means I can have a node from u to, I can have a node from u, node from okay, cool. Node from u to v and also from v to u. I can have the nodes. Cool. Now, with n vertices numbered from 0 to n minus 1, which means the vertices are numbered from 0 to n minus 1. You are given a 2D integer array called as edges. As I have told in the bar graph series lecture 2 also, we can represent a graph in multiple ways. One way to represent the graph is by this edge ka vector. Now, this edge represents that, okay, I have an edge between AI and BI, which means an edge from AI to BI and also an edge from BI to AI. As equal as that. Cool. Now, cool. Return the number of complete connected components. Complete is nothing but that if I have, let's say, one component like this, then my every node should connect every other node in that component. Every node should connect every other node in the component. This component is complete. This is what is called as a complete component. So basically, the identity of a complete component can be what? If I have 4 nodes, 0, 1, 2, 3, I have n equal to 4 as 4 nodes. Now, how many number of edges I can have? Tell me how many number of edges. If I have, let's say, okay, forget the component. Let's imagine you only have this graph. If in this graph you had 4 nodes, and I say that every node is connected with every other node, then how many number of edges will be there? Tell me that thing right now. For every node, I will see that this node connects how many edges? n minus, if in total I have n edges, I want that every edge, which means the node 0 should connect other n minus 1 edges, n minus 1 nodes. Okay, I will have n minus 1 edges for that, right? Okay, let's mark it. n minus 1 edges are done. Now for this node 2, again it has to connect n minus 1 edges. Okay, cool. Again n minus 1 edges for this node 2. Then for the node 3, different color, let's say pink, green. For the node 3, again it has n minus 1 edges to connect to, right? Cool, n minus 1 edges. Now for node 1, which is remaining, again it has to connect to n minus 1 edges, again n minus 1. So you saw, you have n minus 1 edges for every of those nodes. In total I have n nodes and you have n minus 1 edges for every node. In total you have n into n minus 1 number of edges. But here you saw every edge was counted twice. I counted this orange edge also, which means from 1 I counted up till 0, and also I counted the same edge from 0 to 1 also, which means I am in this particular method, I am counting every edges twice. So basically if I do a half of it, it actually will give me the number of edges in my complete component or complete graph. By this stuff, I can just get to know, okay, number of edges in a complete component, it can be, if let's say the number of nodes in a component are, let's say n, so number of edges in that complete component can be n into n minus 1 by 2. If for the example, if it had 4 nodes, so 4 into 4 minus 1, which is 3 by 2, it is nothing but 6. So you will have 6 edges. You will see 6, 1, 2, 3, 4, 5, 6. That is one thing you got to know. Okay, the complete. Firstly, I have one thing for sure know. Sorry if I just beat that stiff very hard, but one thing I for sure know, that I can find component for sure by a simple DFS traversal. Now I will for sure know that how many number of nodes are there, right? For these number of nodes, let's say if this component has 4 nodes, then these 4 nodes should for sure have 4 edges. If it is the case, then the component is a complete component, and I can just increment my answer. So basically I will just simply go do a DFS traversal, find the component. For every component I will find the number of edges inside that component. How I will find that, it's an interesting question, we will see. But as soon as we find the edges in a component, I will just go and say, okay, if the edges are actually equal to n into n minus 1 by 2, it is a complete component. I will just simply do this stuff. I hope that you guys have got it. Let's quickly see that, okay, if I am going on to a component, how will I find out the number of edges for that component? Although I can for sure say, okay, the component has n nodes, so it should have the n into n minus 1 by 2 number of edges. But also I have to parallelly find out the number of edges also in this component which has those 4 nodes. So basically now my task is, because see, it is like, okay, LHS, it is the LHS. Now I have to verify with the RHS. So RHS also I have to find, right? Only in that condition I would be able to say, okay, that component is complete. Component with the 4 nodes should have these number of nodes, but actually what number of edges it is having, sorry, component with 4 nodes should have these number of edges. Actually I have to find, okay, these 4 nodes are having how many number of edges actually. That is how we will find out is, I will actually go on to this graph, which means I will just simply go on to this graph now. Let me just quickly make that again. 0, 1, 2, 3, 4. If we just have to find the number of edges in this graph, let's say I have found this graph. Now Aryan, how to know that what graph is found? Because in component I just go on to nodes. So when I will be iterating on the component itself, I would only be doing all the nodes itself, right? So basically if I just go on to the component, so I just know, okay, in the component right now I have 0, 1, 2 and 3. Now involving this 0, 1, 2 and 3, how many number of edges are there? What I will do is I will just go on to the adjacency list. of my 0, because how the 0 will store the information as 0 up till, okay, it will just say, okay, my node 0, it has an edge to 1 and 3. Node 1 has an edge to 0 and 2. Node 2 has an edge to 1 and 3. Node 3 has an edge to 0 and 2. It is how our adjacency list is made. So I will just go on to the adjacency list of every node and we'll check, okay, it just represents 0 has 2 edges. 0 has 2 edges because its adjacency list size is 2, which means 0 is connected to other more 2 nodes, which means if I am connected to other 2 nodes, I will be connected by only an edge. So I just can say, okay, 0 has 2 other edges. Okay, 0 has 2 edges, 1 has 2 edges, 2 has 2 edges, 3 has again 2 edges. Now, by this I can just get to know, okay, these all have in total 8 edges. But actually I saw one thing. I only have 4 edges. How come it gave me 8? It gave me 8 because I counted the n edge from 0 to 1, and again from 1 to 0. That is the reason it is being double counted. That is the reason I can just do a 8 by 2, which means I will just go and find. Firstly, I'll just go, and before that, if you guys are liking it, then please just smash the like button. That would be really helpful. Now, what we did was I just went on to the component. By the component, I just know, okay, what all nodes are in that component. If the nodes are, let's say, n, so the expected number of edges which needs to be there should be nothing but 6, which is n into n minus 1 by 2. But then what I did was I just went on and find, okay, how many number of edges are actually there. So I went on to the adjacency list of this particular nodes, which means 0, 1, 2 and 3, and then I tried to find all the contribution of every node, which means every node has contribution of how many number of edges. It has 2, it has 2, it has 2, it has 2. Then it just have addition. Okay, number of edges in total are 8, but in this 8, every edge is being counted twice. That's the reason I have to do 8 by 2 and get a 4, which means, okay, I have 4 edges. So basically this node 0, 1, 2 and 4 is having 4 edges. It should have 6 edges, but it's having only 4, so it is not a complete graph. While if it would have been having 6 edges, then it would be having R6 as the answer, and that would be the 6th number of nodes. So it is simply that I will simply go on to my every component, and simply go on to every component is nothing but a simple DFS traversal. You will just entirely go on to this component. When I start from 0, I'll just go and check, okay, nodes in this component right now are 0, 1 and 3. The component's size is nothing but, let's say, 3. Number of edges it needs to have, which is the expected number of edges it needs to have, is nothing but 3 into 3 minus 1 by 2. It is actually 3. Expected is 3. Actual one, I'll just go on to the adjacency list of this all 3 nodes, which is 0, 1 and 2. I'll go and find number of edges contribution. It has 1, so it has 2, it has 2, it has 2. The sum is nothing but 6, but repeated twice, so upon 2 it is nothing but 3. Both 3 actual and both 3 expected are matching. For sure it is a complete component, and I can simply add a +1 because see, I have found one complete component. I can simply go on the entire graph and just see, okay, what all components are complete. Here all the components are complete. That's the reason my answer is 3. One for this, one for this, and one for this. I showed you how you will find the complete component. Cool. That is all, and the constraints were actually nothing but O of n only. So we can simply, all the constraints are pretty less, but we can actually solve this problem in simple O of n time by simple DFS traversal. That is it. That is it. Actually, that is it. Cool. Let's quickly jump on to our coding. That is also pretty easy. But before that, if we can actually please, let's reach out to 60 likes. That would be great. Awesome. That would be awesome. Just 60. Cool. Firstly, I will just simply go on and firstly, because of this vector of edges, I have to make a graph as adjacency list. Now, adjacency list is nothing but node to the pair of nodes. I hope that I am visible. I'll just quickly check. Yeah, I am. So basically, it will be nothing but node to all the nodes it is connected to. So I will just make a simple. I can have anything vector also, but I just take a map. Actually, same as how we build a adjacency graph. So I just have the, okay, from this node U, all these nodes V are connected for this graph. Then I went on to every of the edge to actually make a connection of this graph GR. which means from this node U, I can go to node V, and for sure vice versa also, which means it is an undetected graph. So node V, I can actually go on to node U also. Cool. Then it is a visited array to actually make sure that I am traversing every node exactly once, because it's a DFS traversal, and for that we need a visited array. Now it is my answer. It is my answer which is actually showing the number of complete connected components, and then I will just go on to every of my node. If it is visited, just continue. As simple as a normal component we find out, we just do a simple DFS traversal. If it is visited, we make sure that we will not visit the same stuff again. So just return, which means just continue. Else I will just try to find, okay, the component stuff, which means in this component right now, what all nodes will be there, because for every node I will have to go at the adjacency list. So for that I will need, okay, what is the component, actual component, which means what all nodes are in that component. So I will have this component vector which I will pass in the function of DFS itself, this DFS function. Now I will just go and call this function of DFS. Firstly, a base condition of my recursion is always a base condition. If it is already visited, just go and return. If it is not, then firstly make sure to visit that number, and also you are visiting that number, right? So for sure you are adding that number in your component. So add that number, not that finger, but yeah, add that number in your component itself by just adding that component and adding that node itself, which is I node. And for sure a standard condition, if you are on a node, just go on to your neighbors and try to visit your neighbors as much as possible. So I will just go on to my neighbors of my node I, and then I will just check, okay, if it is not visited, which means if the visitor of that neighbor is false, only then visit that neighbor as a simple DFS traversal. And ultimately this component will get pushed in by all the nodes that are actually making my particular component. And ultimately after my DFS is done, my component will have all these nodes. Then I will just check, okay, what all number of edges are there. I just went on to my entire particular nodes of my component, because my component, let's say, have a node 0, 1, 2 and 3. I will go on to 0 and I will find, okay, what is the actual number of edges my node 0 has. I will add that in my edge, and then the node's contribution, which is okay, node 0 has nothing but 1 and 2 as the other members in its map or adjacency list. So it is nothing but the graph of that number dot size, which is the adjacency list of that element size. And then by this I will just get all the edges in my actual graph, which actually I am having. But as you saw, that actual number of edges are nothing but ed by 2, because every edge was counted twice. But then you will just go and find the connected component whole size, which is nothing but, if you had 4 nodes in your component, so you want your answer as, if you had 4 nodes, then you want your answer as 4 into 4 minus 1 by 2. But actually I will just do so basically I want my expected component size is nothing but CS into CS minus 1 by 2. Now I will just have to compare, this stuff right here, which is the expected value, and it is the actual value. I have to compare both of these two, and it should be equal. If it is equal, then I have to increment my answer, because it is now a good or a complete connected component. And ultimately I will just run the answer. I hope that you guys got it. And that is all for this particular problem. If yes, then please let's hit the like button. Let's reach to 60 likes, and then I'll just quickly read the comments, and we'll quickly end the stream in just 5-10 minutes. That will be great. But yeah, if you guys have any question, or if you guys have liked the stream, then that would be really helpful. If you can just please hit the like button, that would be great. Cool. Let's quickly read the comments too. Chalo bhai, problem solve karte hain ab, lol. Nishant. Ayush, are you saying only problem solving is enough for the questions? Pratik Mehra. Oh, Pratik Mehra. I guess this Pratik Mehra is apna wala. Yeah. Hi Pratik. Hi bro. Ors. If you don't know, Pratik is from our college itself, one of my friends, great ones. Cool. Divyanshu Bhartiya. How can we solve the 4 question using DSUs? See, DSU is nothing but giving you the functionality of finding the component very easily. Either you can just go and find the component. See, DSU is a bigger brother of components itself. So anything which you can solve by a DSU, sorry, anything which you can solve by components, which means a simple DFS, you can solve by a DSU itself. So for sure, any day, just because see, a DSU is nothing but just, okay, my tablet is done, I can just switch back to a camera stream. So now simply a DSU is just getting you the, okay, if this node is in this component or not, if this node is in this component or not. So simply you can just, although it will just become very, very complex for this simple problem to apply DSU, but still, if you just want to go on, you can actually apply it using a DSU also. But I highly not recommend it to even think in that way, because it's not recommended. I have not done graph and I have to do less questions on, DP. I have done less questions on DP. So I get demotivated when I questions in contest from the, see, never get demotivated. Just make sure, okay, you know a rough structure of graph. See, if you have been watching our questions daily of Leetcode from the past 1 month, I can guarantee you that you will at least not get demotivated by just looking at the questions. We have solved around 19-20 questions on DP and graph lastly by just new medium and hard questions in graph and DP itself, both of them. So if you just try and come with us daily and try to solve those questions daily with us, for sure, I make sure that you won't be able to ever be able to have a moment and you will encounter demotivation by solving this question, because you know I have learned. And just make sure that either you make your own notes or I actually give you my own notes every time I give a lecture, so you can just have that notes at a particular place. Or else I'm building my website, like we are building the website, it will be live soon, then you can just actually refer that website whenever you want to go to anything. Just go and click aryanmittal.in. You can just go to that website and you will just see stuff, but still it is in production, it is in actually building stage. So right now it is not live, but yeah, I'll just recommend one thing. Just solve just solve that problem by yourself or by seeing the solution. Anytime you get the intuition, that will actually grow on to the things you learn for this problem. Just saying that solving problem, initially it's a bit demotivating, you will get demotivated, but don't get worried at all. Just keep solving, just keep up solving, and for sure you will get better at it, for sure. कूल आशीष पाल सर्विस नाउ कंपनी में है अजय भाई या निशान, चलो प्रॉब्लम सॉल्व करते हैं हम लोग. गॉट इट आशीष भाई, अपना लिंक्डइन देना आशीष पाल. लेट्स कनेक्ट ब्रो. हाउ टू यूज DSU इन दिस क्वेश्चन फॉर एंड नोट्स वी हैव NC2 edges. Correct, that is actually correct. And MS on my 2, that is correct. Aryan bhai, I am planning to do a simple project using JavaScript and React.js. Is it good to go as my placement will begin in 3 months? See, as in if you're doing a simple project and the placement is in 3 months, considering see, if that project can be completed in a week or at max 1.5 weeks, then I will highly recommend it. If not, then just get the projects from the internet, and if you know JavaScript and React.js, then for sure you might, if you're actually planning to build a project on JavaScript and React.js, then for sure you must be knowing that stuff too. So for sure, just make that stuff, but don't give that much time on dev if you are planning for placements. If you have plans for open source, maybe that stuff, and not problem solving, or maybe see if you have plans for startups or maybe some open source or remote jobs, then dev projects are actually very, very, very great. And I'm not saying it's bad, I'm saying that it has great scope, great income. But if you want to go a standard, positive, concrete path, which means, okay, if you do this, I can assure you, you will get a job for sure. But in dev, according to how good you are and how much time you give, and see, how good you are actually implies on this also, but it is more of completed. Okay, maybe next year also, if you just apply for the job again, then still you will be asked the same stuff. But dev is something that every other startup will require, or every other company or every other remote job will require a different demand from you. So that is the difference between them. But actually both are good. But at this point of time, if you are in the college, as your placement is in 3 months, I'll highly recommend, highly recommend, just go and do the tech, which means this coding part, and also make projects for sure, but just quickly wrap it up. Like we can't give much time to it. Great solution. Thanks, Ajay bhai. Sukhpreet Singh, hello Sukhpreet bhai. Today 404. That is great. We actually aim to see. It is what will happen if you just go on and watching and solving problems daily. There will be a time then you will actually be able to solve a hard problem also 4x4. So just be consistent, solve the problems. I'm not saying to watch the stream itself or watch me solve the problem, but just solve the problem. That would actually be helpful for you guys to get good at problem solving. What is the Leetcode handle? Can you type here? That is Aryan underscore 0077. Aryan underscore 0077. That is the title which I have. Maybe you're asking, I don't know why. I just pinned that stuff. Yeah, I just pinned. So it is my Leetcode handle. For sure. Now today's okay, but virtual diya late ho gaya tha. No worries. See, it is, yeah, I also got late, but still I gave the contest. No worries at all. We just have to do the contest and get it done. See, okay, how we are performing in actual real life. I'm an average coder. I want to improve for my placements next year. Can you give me some structural order? I should learn concepts. Study on manipulation. It's a good start. What next? For structural ordering, see, as such, programming has no structural orderings, which means your graph is never dependent upon your DP. Your arrays is never dependent upon your DP. Your bit manipulation is never dependent upon your graph, which means everything is discrete. Sorry. If you have been solving the problems from the last 1 month, I have covered entirely every kind of problem which you will encounter in future. So if you have been watching us solving problems daily for the last 1 month, just 1 month, we have encountered every kind of problem to start off with, which means we have encountered binary search, we have encountered bits, we have encountered tries, we have encountered graphs, all types of, which means DFS, BFS, everything which we encountered. We have encountered DP, a very good problem of DP with bit masking, 1D, 2D, 3D, many all. And we also encountered priority queues, stacks. We have done a problem for every kind. So it is not that you cannot start off with, which means if you have solved a problem of every kind, then you know that concept, which means now you will be able to solve a problem on arrays. You will be able to solve a problem on maybe queues, graphs, DP. So it is that okay. If you had solved, then I can actually say okay, and now. And if I just again ask you to solve that same problem, then you should be able to solve it. If it is the case, then you are good with actually not going back to the concepts. See, going back to the concepts is just okay. Going through the playlist itself just quickly and just say, okay, it is one concept. I never knew that. Now I know that. But I'm not saying to actually go in the entire, if you have done the last 1.5 months or so, or 2 months with us the problems, then going on to the entire playlist and watching that again won't help that much. Just solve the problem. If you have time, then you can actually go and watch the playlist entirely. But if you don't, then just solve the problems as we encounter the new problems itself. Then the concept will for sure come with that problem itself. But if you still want to know the concepts only, then for sure the playlists are actually awesome. See, the main hard parts are bits, DPs and graphs. Rest of the stuff are entirely array based, which means array entirely involves our priority queues, stacks, queues, everything comes in the array wala questions. So if you just go and watch the array playlist, we have the questions of arrays, which will actually involve every kind of question. Two pointers, sliding windows, Cuddy's algorithms, and every stuff. So it's actually good that we actually solve like this. I have the entire playlist. Just write array problem solving by Aryan Mittal on YouTube. You will get the array problems. Just write stacks problem solving by Aryan Mittal on YouTube. You will get the stack problem playlist. Queues problem playlist. DP problem playlist. So basically, for any stuff, just write graph problem solving by Aryan Mittal. You will get the playlist of just graph problem solving. That would be just great. Cool. You are a gem donor. Thank you so much for all your contest discussion. Thank you so much, Ashish Pal, for these great words. By how to get interview call, I'm not, and I want one-to-one discussion. What things you follow to make yourself good at problem solving, and how do you revise for the topics? So yeah, basically, if the folks are right here and you are still watching, then if the likes can actually reach to 60, that would be great. If you are actually watching and you have liked it, just go and make a call to your friend and share the link with him and ask him to like it. But yeah, jokes apart, to actually get a call from interviews, firstly we have to actually build a resume well. You can just connect with me on the LinkedIn and share your resume. I can just actually review it. Maybe I can actually review that also in this upcoming live streams. We can have a resume live stream also, resume review live streams also. But for sure, just get that resume done, make it actually look good. When it is good, just go. For sure, the lists of companies are very much on LinkedIn also, and we also have our one video where we discuss about the projects. In that also I gave the entire list of companies. Still, just go on to any name, you know. Let's say if you want to go to Wells Fargo, then just write Wells Fargo career page. You will find the opportunities open. Other way to find out the number of opportunities will be nothing but simply just go on to LinkedIn, write Wells Fargo, go like the LinkedIn opens up, the job portal opens up. Here that jobs will be available for that particular company. In that job area, the recruiters who posted that job will also be there. So you can message the recruiters from that LinkedIn job portal of that Wells Fargo or any company page. It is one way. Other way is find the job ID from the job career portal and then apply by writing Wells Fargo recruiter, Google recruiter. So recruiters of the company will come in, just send them a cold email or a message, which means a connection request with a note attached of entirely about you, everything, and also with your resume. And resume should be well made. That is how you can get a calls. Basically, you will apply at 100, you will get calls from 5 or 10. It is the ratio. So it is nothing but just try out and keep on applying. That would be great. Thank you so much, bro. LinkedIn request accept karo bhai. I just try to, but the worst part is I don't get time to actually scroll LinkedIn itself. But yeah, I'll for sure do it and watch your Insta DM also. Yeah, Insta DM is actually pretty less cluttered, so for sure I will just watch that. Ajay, for sure, it is much easier for me to watch because it is very less cluttered. In LinkedIn, I have around 200 messages piled up. It's just very hard to open them, but still, I guess we can end the stream right here. If you guys have any doubts, and still, if you guys have still watching, those 22 folks, if you can just please like it and reach to 65, then it would be great. But I just wanted it to reach to 60 and it has reached. I'm very happy on that. But yeah, if actually आपकी श्रद्धा, आस्था, इच्छा हो, वैसे मेरे पास तो कुछ भी नहीं है, और आपके पास हो तो you can like it and let's see you guys in the next video. Until then, goodbye, take care, love you, bye bye. Ending the stream, cool, bye bye.